Hello, ladies and gentlemen. Today we are going to talk about a comparison of cuckoo search approach and one-dimensional approach for cutting stock optimizations to take a wise decision in determining the right cutting pattern to meet the customer expectation with a minimum cutting loss. The contents of our presentation will be illustrated as the following. We will start with the introduction, which include overview, problem statements, and also objective, scopes and expected outcome, followed by the methodology, and we will also share given a result and the conclude with the conclusions. We want to elaborate what is cutting stock problem. So, cutting stock problem is the problem of cutting standard size pieces of stock material, for example, paper roll, wood, metal sheet, glass, and they are cut into pieces with the specific size that the customer asks for while minimizing the total waste. There is so many types of cutting stock problem, which is depend on the dimensionality and will classify our type depending on that. So as you can see here, there are two types, which is cuckoo search problem and also one dimensional problem. The other industrial application occur when cutting sheet metal, paper, wood, and also glass. Since there are a lot of wastage during the cutting process, it is very important to compare and determine which is the best method to resolve waste issues during the cutting process. Objective of this project is to develop a tool model for solving the cutting stock problem in aluminium sheet cutting process by using two approach, which is one-dimensional approach and also cuckoo search approach. Next, to determine the best approach that can optimize the remnant produce with percentage coming from the case study. There are three scopes in this project. Include the optimization calculated will depend on the number of length and the size of customer orders of aluminium sheet in cutting stock. Next is the study of this paper applied for cutting stock problem, and the aim of the study is to minimize wasting of cutting stock that can reduce by comparing the two methods. This section explains the specifics of the methodology utilized to carry out this study. Several of these approaches have been developed to achieve the objective. This study suggests creating an analogy that may be applied to a cutting stock to solve the issue. This method is used to fill an order in response to a request for determining quantities of smaller lengths. This study will be focused on an approach utilizing the linear programming solver, MATLAB simulation capabilities, the cuckoo search algorithm, and the pattern generation algorithm. The design will be run through the MATLAB simulations according on length and diameter that the customer requests. The cutting stock model is developed in this study using a pattern-oriented approach. A pattern generation algorithm was created and coded in Visual Basic, MATLAB, one-dimensional cutting stock. The cutting stock model can be developed through applied mathematics, a linear programming model limited by variously feasible patterns. This flowchart shows the flow of the cuckoo search. Start from initialize the parameters by generate initial population with set the initial value of the host nest size probability and maximum number of iterations. Next is randomly generated by Levy Flight. Levy Flight is a build a new nest at a new locations. We use the Levy Flight a fraction of was nest. And then we need to evaluate the fitness by current best solution minus with the previous best solutions. And this process is repeated because we want to get a best solutions. So if the reliability of fitness is better than SSA efficiency, we need to replace the J by using a new solutions. If the SSA efficiency is better than the reliability of fitness, so we need to generate a random number and compare it with the abundations of a fractions. And next is keep the best current and decrease the aberrations of fraction probability, and stopping the criteria. The process is an. This shows the flowchart of one-dimensional. The solution procedure to start the program based on the figure from the input of the stock length, unit cost, number of necessary products, and clicking enter. All feasible cutting patterns are generated by the input values of the length of each item and necessary parameters so that the vector represents a visible pattern that must fulfill the conditions expressed in the condition below. The optimal cutting pattern, maximum and minimum, is then now chosen by solving the linear programming model, which reduces the total remaining pattern. Next, the results are shown on two separate tabs that include the print text solution and the visual solution by clicking on the GB cutting stop program on the button. The total stock material used, depending on the circumstances mentioned below, summary of all SJ and calculated as all used sheet costs are assessed. The total remainder of cuts from the text solution of the linear programming model is shown in figure. The value of the objective function of the model can be evaluated. Therefore, on the second result tab, the graphic solution showing products and of cuts remaining of a different color on each optimal cutting pattern is seen. In the one-dimensional method, the use of that solution to solve the cutting stop problem shown in the table. This table shows the comparison study in cuckoo search and one-dimensional cutting stop results. The cutting stop model and the calculation were created. The calculation was coded by MATLAB, RealCut 1D, and GoNest 1D in one-dimensional and a free direct programming solver called Linear Programming Solve in order to construct a one-dimensional cutting stop program called Linear Programming Cutting Stop Program, MATLAB. The calculation was coded. In the cutting stop problem, the cuckoo search algorithm methodology is proposed to investigate the display of the proposed measurement. Cuckoo search estimation was approved and constructed without CSA genetic algorithm and arbitrary programming and with cutting stop problem. The cutting stop model completely removes arbitrary loss, prevents determining blunders, significantly decreases accumulators watch, and limits the all-out stock use, thus increasing productivity. In addition, the findings were considered against the best arrangement developed by two commercial programming projects for a similar problems. Computing systems typically have excellent results at reasonable computing time and perform better the commercial programming in terms of operational performance, which requires less time to update result. It seems to be considered. Lastly, the general information will be gathered and accessed to settle the malfunctions that they are confronting now by decreasing the percent followed by the case study of the current utilized material. As shown in the table, the result obtained shows the waste will be lower if using a one-dimensional compared to the cuckoo search. It is very obvious that one-dimensional reach approximately 398. A waste that can be minimized by cuckoo search is 626. Compared to a one-dimensional, there is not much less than compared to the other software waste because cuckoo search is very suitable used in linear programming cutting compared to one-dimensional in case study. As shown in the table, if using the one-dimensional, compare the cuckoo search, the result obtained shows the waste will be lower. It is very obvious that one-dimensional reach approximately 398. A waste that can be minimized by the cuckoo search is 626. Compared to one-dimensional, there is a very much less compared to the other software waste because the cuckoo search is very suitable in using in linear programming cutting compared to one-dimensional in this case study. I have now come to the end of my presentation. In summary, I spoke about the cuckoo search approach and one-dimensional approach, which is have a different methods and working to solve the cutting stock problem. The result attempt for the industry also shows a clear difference for computing times, having a similar quality for the results. Google search cutting stock is the best solution compared to one-dimensional cutting stock because of case study, the Google search cutting stock is the most method that can reduce the cutting stock and to solve this problem, especially for large size problems that are extremely difficult to solve. Well, that is all I have for today. Thank you.